Yeah, it's a real honor to be here today. My name is Marek Olszewski. I'm one of the co-founders of Celo. And fun fact, my dad's actually a professor at this university, and so it's an extra treat for me to be here. Today we're going to be talking about the Celo L2 proposal. I'm just kind of curious, how many people here, show of hands, heard about the L2 proposal earlier in the summer? Okay, a few people, mostly in the front. So folks in the back, you're in for a treat. We'll talk about something cool today. And you'll see the use of a lot of emojis today. It's a bit of a challenge for myself this year to make slides with emojis. And so if you like the format, come let me know afterwards, either in person or on Twitter. My handle is Marek _. And so maybe just kind of as a show of hand, who here feels like we are, or they, or maybe their close friends, are kind of using Web3 products on a frequent basis? I'm kind of just curious. Interesting, okay, well this is a good crowd, so about 50% of folks raise their hand. That's actually pretty amazing. That's the first time that's happened. Usually it's closer to 20%, but 50% is not 100%, and that would still make Vitalik sad. Shown here in the form of a cat emoji, because there is no emoji for Vitalik yet. And I'd say it's a shame because I think many of us are really working hard, building for this kind of future where we want everyone to be rushing into the house of Web3. This is kind of a scene from a Best Buy in the US on Black Friday. Probably pretty terrifying in person if this actually happened, but as a metaphor, this would be pretty exciting, right? All of your friends, everyone that you know, all the normies, kind of rushing in to use the products that you're building in Web3. And we're not there yet. This is kind of the current reality. It's just the people who raise their hands in an empty department store, running around and having all the fun. But we're here to change that. And when people ask me what Celo is, one way to think about Celo is kind of an EVM platform that's working really hard to bring about that future that we saw earlier. It's really focused on ease of use, on scalability, and we're just laser focused on making that happen. And so today we'll talk about both, but before we jump into kind of the L2 proposal, I just wanted to give a really quick summary of what Celo is today. So today it is an Alt L1, it's EVM compatible Alt L1 with a really efficient proof of stake consensus protocol that we launched 3 years ago. It uses some of the same cryptographic mechanisms that secure Ethereum to today, but launched 3 years ago, so 2 years before the merge. And then critically, and this comes back to kind of that image I showed earlier, much of Celo is really laser focused on building for ease of use and accessibility. And so that means really great mobile support. So Celo has this thing called Social Connect that lets you send value to phone numbers even before the recipient signs up. And it also has a ZK Snark-based like client. And then critically, you can also pay for gas with tokens on Celo. Account abstraction is a really big topic as of late. And a lot of people are excited about this future where you can pay for gas with tokens. Turns out on Celo you can actually do that today with EOAs. It's supported natively. There's a special transaction type that you can use where you can specify the gas currency that you want to use. And then just as a kind of a cherry on top, Celo launched with full on-chain governance, and one of the first proposals that the community brought to governance was to make Celo a carbon negative chain, which basically means that Celo has been, so the proposal passed, and since then the chain itself has been buying carbon offset credits programmatically using block rewards. And so that's made Celo not just carbon neutral, but even carbon negative. Other chains have followed suit, which I think is really exciting. I think it's made the whole space, it's really helped change the narrative about the space. It's no longer something that's contributing to climate change, but something that is actually helping to fight climate change. And so that's really, really exciting. And because of that, a lot of refi protocols have kind of made Celo their home. And so you can think of Celo as having kind of two really big verticals, a lot of mobile DeFi, a lot of mobile payment products, and then refi products. And all of this has, I think, resulted in a lot of interest in the platform as of late. So even though it's a down market, when you kind of focus on especially mobile payments and kind of mobile DeFi, people tend to think of these types of projects or products as kind of real world use cases. And even in the down market, we're seeing a lot of adoption of these. We're seeing a lot of growth in active addresses. Basically since February, there's kind of been this big jump. And then when you compare us to other chains, Nansen has a really nice table that kind of shows a whole bunch of chains that they're tracking. And frequently, consistently over the last half year, we're kind of ranking #1 when it comes to address change growth. So this is Celo, but I promised to talk about the L2 proposal. So I wanted to kind of switch gears and talk a little bit about that now. You know, one of the unique things about Celo as an L2 is that it's transitioning to become an L2 from an L1, which means that unlike other L2s that are launching today, you know, we have a bunch of constraints that are really guiding kind of our design as we think about what Celo as an L2 should look like. And I would say that those constraints have resulted in maybe two really important design goals that we've been thinking about. The first is around the price of transactions. So because Celo is very scalable today, gas is quite cheap on Celo. And that has attracted a lot of, you know, I mentioned payment use cases, community currencies, micro-lending use cases, universal basic income use cases, types of use cases that wouldn't really make sense on a chain that's charging 20 to 30 cents per transaction. And so one constraint, one design goal for this proposal is to keep gas fees low. And our solution to this is to leverage something called EigenLayer. Maybe just show of hands, how many people here are familiar with EigenLayer? Okay, maybe 20%. So just for the benefit of others, you know, you can think of EigenLayer. It's an Ethereum protocol on Ethereum, the L1. And you can think of it as a marketplace for trust. And the place for trust that EigenLayer went to is Ethereum validators. So who better than to go to the folks who are securing the Ethereum network to build this marketplace of trust. And the way they do that is they allow folks who are staking ETH and running a validator to effectively reuse that ETH to use it as a bond against, to secure other services that they may want to run. And of course, because this is Ethereum, there's a lot of trust, there's a lot of ETH2 validators. And with EigenLayer, folks can opt into running a number of additional services. And one that the EigenLayer team itself is building is this thing called EigenDA, which is a middleware that basically is bringing dank sharding to the Ethereum ecosystem, I would say, you know, 1 to 2 years ahead of the eventual launch of dank sharding on ETH2. And so that's really exciting. You know, dank sharding is extremely bandwidth efficient. It turns out that data availability isn't actually a problem that is necessarily like expensive from a bandwidth or mathematical perspective to do. And you know, dank sharding is really a nice algorithm for bringing it to the broader Ethereum ecosystem. But it is, you know, new, and as a result, it will take some time for Ethereum to adopt it. And so in the meantime, we have folks like EigenDA who are looking to bring it to us sooner. And so that will help us make gas significantly cheaper on Celo. Some people have been asking, well, what about proto-dank sharding? It's coming sooner. Could it be good enough? You know, from everything we see, it looks like proto-dank sharding is not going to offer the same kinds of costs as EigenDA. And so for now, I think we're still heavily in favor of EigenDA. The second goal is one around decentralization. So Celo today is an actual active L1 with a lot of nodes running it, validators, full nodes, you name it. And it would be a real shame to kind of throw all that away and just move to a single machine and have a centralized sequencer. And so instead, we've been working really hard on a design and an implementation that transitions our current validator set into a decentralized sequencer set. And this is elegant for a number of reasons. I think most critically, it gives us better censorship resistance and better uptime. And more broadly, just creates a more decentralized system. And because we've been running as an ecosystem an L1 for a while, we have a lot of expertise in consensus protocols and how to do this in kind of a production-ready kind of manner. And then the third and final goal, and for the folks who are paying attention, you might be wondering, wait a minute, that doesn't look like the number 3. And it's true, it's not how I would show the number 3 with my hands, but it is the only emoji for 3 I could find, so we're gonna have to live long and prosper for now. But I think for the folks who are even more astute, I said there were 2 goals that we were kind of targeting, but as is typical with big software engineering projects, you end up realizing that there's actually additional constraints that you might have. And that one ultimately kind of created this third goal, which is one around finality. So, with this kind of laser focus on ease of use in the ecosystem, Celo launched with 1 block finality, which means that there are no reorgs on Celo. There's basically a proof of stake protocol that creates token economic securities that prevent these types of reorgs. And that is really nice for payment use cases, for anything involving normies. Trying to explain to a normie why their transaction might roll back is something that we didn't want to do in our ecosystem. And so we worked really hard to offer 1 block finality. And keeping that as an L2, it turns out is not that trivial. All L2s today, as far as I'm aware, do not offer this. And so we worked really hard to create a design that actually allows us to offer 1 block finality as an L2 as well. And when you think about the sources of potential reorgs in an L2, I would say there's 2 sources. There's the L1 itself, right? Ethereum can reorg. And then there's also the L2 itself, which could potentially reorg. Say a sequencer shares one thing with one party, but then ends up doing something else, perhaps posting a different transaction bundle to Ethereum. That could cause someone to go, oh, wait a minute, I thought this transaction would be included, but it turns out it wasn't, and therefore I have to reorg. And so the design that we came up with basically solves both of these problems with 2 changes. The first is to add slashing for equivocation. So if our decentralized sequencer ends up signing off on 1 transaction bundle, broadcasting that out to the L2, but then ends up signing off on another transaction bundle and putting that on Ethereum, then those sequencers would be potentially slashed. And so that's one way to use economic security to prevent kind of the L2 reorg. But the other thing that we can do is to prevent the L1 from impacting the L2, and to do that we can add a delay to all forced transactions and all deposits that basically is over 12 minutes to allow the L1 to achieve finality before those transactions make it over to the L2. And it looks like we lost the slides. Looks like the whole projector shut down. So anyway, I'll talk without the slides while they get it figured out. So what does all of this look like? Well, this part is going to be the most challenging because I had a nice diagram with our sequencers on the left, eigen-DA nodes in the middle, and then a bunch of full nodes on the right with Ethereum below. And I was going to kind of walk through basically the life cycle of a block. And so it might be important to have the slides for that. So I'll give the folks maybe a few more minutes for that. In the meantime, anybody have any questions or any thoughts, or want to share any excitement for ETHWarsaw? Is this your first ETHWarsaw, guys? It's everyone's second ETHWarsaw. That's really impressive. Holy shit. Yeah. Well, I could perhaps rotate this TV, and then people could kind of look at this one. Maybe that's going to be better. How's it looking back there? I see two people up on a ladder working really hard for you guys. Did anybody go to the party yesterday? Yeah? Two people went. Nobody else went? Okay, a few people went. Okay, who's participating in the hackathon? How about that? Okay. Any exciting ideas? You guys targeting DeFi, ReFi, NFTs? None of those. Infrastructure, I'm guessing. Okay. Yeah. Yeah, it's a really great question. So for those who didn't hear it, the question is, as Celo transitions from an L1 to an L2, what will people have to do? And the answer is, well, it depends what role you play on the network. If you are a node operator, like running a full node or a validator, then certainly you're going to have to upgrade your node. But beyond that, it should be seamless for everyone else, because the plan is to hard fork into becoming an L2. And so this will be a really nice seamless upgrade. And while we're talking about that, people sometimes ask me, well, what's the timeline? Where are you along this kind of journey? And the journey really started at ECC when C Labs, which is the company that I work for, and I made a governance proposal to transition Celo to an L2. That received a lot of, I would say, great fanfare. Both people in the Celo community and the Ethereum ecosystem were generally quite supportive, I would say. And that followed with an actual on-chain governance vote, where people actually voted to kind of enshrine kind of this proposal as kind of a roadmap direction for the ecosystem. And so that proposal passed with flying colors. It was 99%. And since then, the team has been working really hard to execute on the proposal. Obviously, a lot of thought and work went into it before we even proposed it, including kind of this architecture that I'm going through. And we started building. We are waiting for EigenLayer and EigenDA to launch, because that's a pretty pinnacle kind of piece of the proposal. And so, that's going to launch in kind of Q3, Q4. And after that, hopefully we'll be able to kind of do that hard fork. But it is going to be 2 hard forks, and the first of which is actually happening next month, or this month, I guess. It's September today. So keep an eye out for that. And then after that, once EigenDA launches, there'll be the second hard fork to kind of make that change. So it should be seamless, similar to the ETH2 merge. Hopefully it'll be an exciting moment for the whole ecosystem, but it won't require any work for anybody building on top of Celo, or anybody using products built on top of Celo. Which means that if you're participating in the hackathon this weekend and you're excited about having an L2 that allows you to create really easy-to-use experiences for your users. If, for example, you want to create something that allows your users to pay for gas with tokens, maybe they're sending stablecoins around, and you want them to be able to pay for gas with that stablecoin, you can do that today, and when Celo hard forks into an L2, then you won't have to make any future changes either, and so that's quite elegant. I'm going to assume that they're not going to get this fixed in time. Yes, second question.
Thank you. I saw a proposal some time ago that Celo is moving to OP stack from Optimism, and today you mentioned eigenlayer. And I wonder if these are two different proposals or both things are in your roadmap?
Yeah, that's a great question. So both things are in the roadmap. And so to provide these kind of three features, decentralized sequencer, cheap transaction fees, one block finality, there's no off-the-shelf L2 protocol that we could leverage. And so we knew that we had to kind of roll up our sleeves and really get to work. But we wanted to start with an existing code base that's kind of been thinking about this for a while and that has a nice modular architecture. And the OP Stack has that. And so we've been chatting with the OP Stack team about bringing some of these as public goods to the OP Stack ecosystem. So, obviously, Optimism and others, are interested in having decentralized sequencers. I think alt DAs is something that they've long talked about. One block finality, I think, might be a little bit more bespoke and unique to Celo. But, certainly we're working hard to make these effectively public goods that anyone can benefit from. Hey, we're back. Incredible, yeah. Thanks, guys, for working so hard in the back to make this happen. That looked stressful. Okay, so this is the picture that I tried to describe. I wanted to kind of walk through the life cycle of one of these kind of blocks that kind of goes through the L2. And as with any L2, everything starts with a transaction bundle. In this case, proposed by one of the sequencers in this decentralized sequencer set. So these decentralized sequencers, they make up a kind of a set of folks participating in BFT-based consensus. In BFT-based consensus, you have the concept of a leader. One of these leaders kind of proposes basically a bundle of transactions that it pulls from its mempool, and then it broadcasts it to all the other sequencers through BFT-based consensus. Those other sequencers will effectively sign off on that transaction bundle. And the way we do this today, and the way that we're going to be doing this in the L2, is we use BLS signature aggregation so that we can actually create a multi-sig of all of those signatures. And then we also include a bit vector so that you can have attribution so you can see who signed off on that block. And then we send that to kind of the EigenDA middleware. And EigenDA will effectively guarantee that this data becomes published on its network, and in so doing, it then returns a EigenDA certificate that is effectively a proof that that data was published. And now we have the certificate. And so now is the interesting part. So now we post this certificate to Ethereum. And this allows us, in effect, to basically order all transaction bundles that are being proposed by the L2 using the L1. And then any full node on the network can actually download the certificate from Ethereum, and then begin the kind of block derivation step. And the first thing it has to do, of course, is to go to EigenDA, turn that certificate into a transaction bundle and into that BLS multi-signature and bit vector. And once it has that, it has everything it needs to effectively sync with the L2 for that block. It can execute those transactions. But before it does that, it has to first check that this multi-signature is valid, that 2/3 of the sequencers in fact signed off on this transaction bundle. And it does that by looking at the bit vector, aggregating all of the public keys for all of these sequencers, and then verifying the signature with this kind of group aggregated public key. And this is important because I think some folks, when they think about decentralized sequencers, they say, well, we can check this on Ethereum, right, in a smart contract. And that's definitely one design that has been floated around. But if we do this at the full node level, then we can do this in a way more gas efficient way. And so it's a pretty nice kind of little innovation. Now, and once all of these things check out and you actually execute the transactions, you end up having kind of this derived block. Now, one thing that OP-Stack does that's really quite nice is it has a P2P network that allows nodes on the L2 to gossip these things called unsafe blocks. So these are blocks that have been signed off by the sequencer, but that haven't made it through the L1. And so we're keeping this as well. But when you do this, you have kind of this interesting potential issue, which is that if those unsafe blocks differ from what you're now seeing coming through the L1, then you have kind of the potential risk of a reorg, right? Like if you see something different on the P2P network than you see from the L1, you might end up having to reorg, and so that kind of creates an issue for our one block finality. And the solution here is, of course, what we talked about before. If any full node sees this, then there's evidence that the decentralized sequencer set equivocated, and you can use that evidence to effectively slash them. And this is something that we do today. We have this in the L1, and so we can reuse this to effectively add slashing for equivocating in the L2 as well. Cool. So in summary, this ends up giving you low gas fees. One of the things that I think few people realize when you're using most L2s today and you're using the L1 for data availability, you're paying 95% of your gas fee is going towards just data availability. And as I mentioned before, data availability is effectively an embarrassingly parallel problem. You can actually solve this in a way that requires much less bandwidth, much less trust. And so by using EigenDA, we can in effect slash a big portion of that cost, up to 95% of it. And one of the really nice things about EigenDA, of course, is it's still run by Ethereum validators. And so it offers really nice trust assumptions. We also have great decentralization through this decentralized sequencer set, and this is just really helpful for uptime and for increased censorship resistance. And then finally, one block finality. We really believe that it's quite helpful for users, for developers, building for users who don't want to be confused by things like reorgs. But we also think that this could be interesting for L3s. If you're interested in launching an L3 that can offer Ethereum security, but also cheap gas fees and one block finality, then the future state of Celo could be actually a nice place for you to roll up to, because you'll get to inherit all of these kind of benefits that we're working so hard to provide. And then coming back to that question from the gentleman there earlier, all of this will be done through a hard fork, and so it'll be fully seamless for users and people deploying contracts on top of the platform. And that's, of course, really exciting because if you're, again, participating in this hackathon, you're excited by what you're kind of learning about and you want to build on top of Celo, you can get started today, and then when the hard fork happens, all of that, you'll get all the benefits of Celo becoming an L2 in the future. And just on that note, if you are interested in building something this weekend, and perhaps you're interested in kind of building for people on mobile devices, you know, there's 7 billion smartphones now in the world. I think 80% of people say they use a smartphone on their toilet, which is an incredible stat because it means that 20% of people lie. You know, there's a lot of eyeballs to be had by building on mobile, and if you are interested in doing so, I would highly, highly recommend checking out ETHWarsaw. ETHWarsaw really exemplifies an app that is leveraging all of Celo's features. So you can pay for gas with tokens on Celo. You can send a stable coin to someone, pay for that transaction fee in that stable coin. You can sync your contacts with the app and send value to phone numbers. It's really quite elegant. And it's also a signing wallet, so you can use it with your dApps. One thing that we keep hearing from dApp builders at ETHWarsaw is, hey, having a web app is cool, connecting your wallet to it is nice, but really I want to be closer to the user. I want to offer functionality in the wallet itself. Can you help me do that? And the answer as of recently is yes. ETHWarsaw now is offering this thing called shortcuts, which are these kind of one-tap actions that you can kind of send via push notification to your users through the wallet to kind of push them through maybe some funnel that you have, get them to go to the next step. And so if that's at all interesting to you, definitely check out ETHWarsaw and the docs for ETHWarsaw at docs.eTHWarsaw.xyz. It's really nice for kind of building these really easy experiences for your users. So that's everything. Yeah, thanks for bearing with me through the technical difficulties. And yeah, I'm around if you have any questions.